Okay, welcome to the factor theorem, part 1. This is kind of an important, it's basically putting everything together that we've done previous, and it's kind of our big goal. And so I wrote down what our goal actually is. And our goal is somebody gives us a polynomial, some p of x sort of function, and we want to try to get it factored. Now, we've done this to a certain extent, right? We've taken polynomials that looked like this, say x squared plus 5x plus 4, and we've learned in a couple of different strategies how we can get this thing factored, right? We were able to take it from this form and say, well, yeah, we need x times x, and then we needed a number times a number to make positive 4 in such a way that it adds up to positive 5. So this would be the factored form. Now, what we're going to do is we're going to deal with polynomials that are a little more than x squared. They might be x cubed or x to the fourth, but it's still the same goal. We want to take it from this form and rework it and get it into this form. Okay, so let's just talk a little bit about what a factor actually is. And just to kind of understand, I just thought I'd talk about with numbers, like say factors of 6. If I said to you, what are factors of 6? You'd probably list them and say, well, there's 1 and 6, right? 1 times 6. And then there's like 2 times 3, okay? And that's it. Now, why are these the numbers that we call the factors of 6? And I guess the reason is, if we picked one of these numbers, say we picked the 2, if I divided the 6 by 2, I would get my quotient, which in this case is 3, and more importantly, what's my remainder? There's always, the remainder is always 0. And that's why we call them factors, okay? When you divide a number by another number and you get a remainder of 0, then we call that number a factor. In the same kind of way, okay, if we look at this, x plus 1 and x plus 4, we could say are factors of x squared plus 5x plus 4. And the reason that we'd say they are factors, so I'm just going to say x plus 1 is a factor of x squared plus 5x plus 4. Now, why would we say it's a factor? Well, okay, this is the factored form here. But let's look at the comparison that we did to the numbers here. What if I took this x squared plus 5x plus 4 and I divided it by x plus 1? Okay, so if I took that and I divided it by x plus 1, what would I expect to see as the remainder? I don't even care what the quotient is. What would the remainder have to be in order for me to say it's a factor? Well, the remainder would be 0. So where this is going to is, why don't we just examine remainders? And then we know if we have a factor. I mean, all we really have to use is the remainder theorem. And that's kind of what the factor theorem is, but you're looking at it through the ways of, is it a factor or not? And so we're really still just analyzing the remainder. So if you remember the remainder theorem, it's pretty easy. What would I have done to establish the remainder in this bit of division here? I would plug negative 1 into this function here. So I would have gone negative 1 squared plus 5 times negative 1 plus 4, and then that tells me what the remainder is. So this would give me 1, and then I'd get minus 5, and then plus 4. So I go, oh, well, guess what? That turns out to be 0. And if we get a remainder of 0, yes, it is a factor. So, yeah, it is a factor. Okay, now we kind of knew that it was because we had picked it from this factored form up here. But let me do an example now where we don't have the luxury of seeing this laid out in front of us. So let me clear off the screen. And in this example, we are going to determine if the following, x minus 3, is a factor of, and here's our lengthy polynomial, and you can see it's a little more involved than the polynomials that we did back in Math 10. So I've gone up to an x cubed and got a bunch of other stuff here. Okay. So really, what am I going to do to see if it's a factor? I really just want to look at the remainder. That's what I want to look at. I want to see if the remainder is 0. So what number makes x minus 3 become 0? Positive 3. So that's what I'm going to plug in. I'm going to plug positive 3 in for x. So away we go, plugging in positive 3. And we still got one more spot to put it in. And now all we got to do is crunch out these numbers and see if we get 0 or something else. Now 3 cubed is 3 times 3 times 3, or 27. And here we have 3 times 3 squared. 3 times 9 is 27, minus 13 times 3, which is 39, minus 15. Well, if you crunch these through on a calculator or you just do the math yourself, okay, it turns out you get 0. So, is it a factor? The answer is yes, it is. Okay, and that's where I'm going to stop for now. That's just the beginnings of the factor theorem, and you can see it's a pretty important starting point. So we're going to continue with part 2 in a bit.